Okay, today we are going to talk about rational expression. Rational expression, and this chapter assumes that we do know how to do a basic polynomial factoring. So before you start this chapter, this topic, I would strongly recommend you to go back to the factoring lectures and make sure that you fully understand those chapters, those topics, and factoring techniques. Otherwise, this would be not that easy to understand, right? Not that easy to understand. Okay, so rational expression, as you know, rational expression is very similar to rational number. Now, many of you already know what rational number is, right? Rational number is basically number that has a over b form, rational form, number form, and this a and b, they both has to be integers, right? If any number that you can put it in a over b form, then that's going to be a rational number. Well, rational expression use almost the same format, a over b format, but instead of using a over b as a number, they're going to use polynomial. So polynomial over polynomial is going to be what's called rational expression. So, so a simple example would be, something like the 2x squared plus 5 over x squared minus 4. Something like that. That's nice polynomial. That's another nice polynomial. So something like this is called rational expression. Another example would be, I don't know, x over x minus 1. Simple, or simpler. Then again, this is nice polynomial. That's another nice polynomial. Sometimes we have more than one variable, so it's possible to have like xy squared over x squared plus y squared, something like this. So all of this is considered as rational expression. Now, so let's go to first example. One of the common example in this topic is reducing to the lowest term, right? So example, reduce to lowest term. Okay, so basically what they are asking is factor if you can and cancel the same common factor top and the bottom and reduce it down to the simplest form. So example would be something like this. Let's say we have x squared plus 4x plus 4 over x squared plus 3x plus 2. Let's say we have something like this. Now what we try to do, we try to reduce this to the lowest term, meaning we need to factor this and we need to factor this. Remember, this is particular type of factoring when we have no number in front of x squared term and we have bx plus c form. Then remember that one, we put it in this form, right? Put it in this form and try to figure out this two number combination. multiplied to be 4, added to be 4. Oh, that must be 2 and 2. So plus 2 and plus 2. Just like that. Okay, and same thing goes for the bottom part. We put it in this x and x form, and multiplied to be 2, added to be 3. So that must be 2 and 1. 2 and 1. All right. So see right here, we have x plus 2 there, and we also have x plus 2 there. So this cancels with this. So they are cancelled. So our final answer should be just x plus 2, which is this one right here, over x plus 1, which is this one right there. Now, we also have to mention a particular x value that we do not want as our answer. You know, the x value that will make denominator goes to 0. We do not want that, right? None of us like to go that denominator becomes 0, right? None of us wanted to go there. Why? Simply because it's undefined. Undefined means what? Means they have no idea. And mathematics is a field that they like to prove every single thing. And they hate, well, I shouldn't say hate, they really don't like the idea of undefined, do not know. So they really don't want to go there. So what x value will make any one of these denominator, even before the canceling? Let's look at this one right here. If x equal what value, this whole thing is going to be 0. Well, if this is minus 2 plus 2, 0. So we do not want x equal to negative 2. Same thing from here. We do not want x equal to negative 1, right? Because if it's negative 1 plus 1 becomes 0, and that makes denominator equal to 0. So our answer is this, but we should definitely have to mention this as well, right? Okay, another example. Let's say we have x to the third minus 8. In the bottom, we have x to the cube minus 2x to the square, right? You know, all those videos that you are watching, whenever that I'm giving you an example like this, if you can, it'll be great if you can pause this video right now and try this on your own and check the answer with me, right? Okay, so this also basically a factoring question. If you can factor this and identify common factor, and that's pretty much what they mean by reducing to the lowest term. Remember, this was one of those formula type of factoring, right? Remember that we had like x to the cube minus a to the cube, right? This was what, when we factored this was x minus 2, right? X minus a, and x squared plus ax plus a to the square. Remember that part? Well, if you do not remember, then you should try to memorize this. If you do not memorize this, then simply you cannot do this question, right? So let's assume that you memorize this formula and you know how to apply this, because what's this 8 is actually 2 to the third, right? So in our case, our a is 2, so this can be factored as x minus 2 x squared plus 2x, which is ax, plus 2 squared, which is 4. Right, just like that. Okay, the bottom part. Now, what do we have in common between this and this? Well, we have x squared in common. Then, if you factor x squared out, what's left behind would be x, and from here, it would be 2. Okay, now identify the common factor, top and bottom, cancel. So what's left behind would be x squared plus 2x plus 4 over x squared. Now this is a fine answer, yet we need to mention what particular x value will make any one of these denominator, right? Right here, or here, or here, right? Equal to 0. So from here, when x equals 0, then this becomes 0, and this whole thing becomes 0. So we do not want x to be equal to 0. Now from here, we do not want x to be equal to 2, right? So this 2 plus this would be our final answer, right? Okay, so they are pretty much the same, right? Pretty much the same. Just testing the factoring technique, see if you can factor properly and identify common factor and get rid of that, cancel it, and also identify a particular x value that makes denominator equal to 0. All right, let's do next example. Next example is similar, yet slightly different. We have to be a little bit more careful because we have to play with the sign, the negative value, right? So let's say we have something like this. Okay, so the top part, try to factor whatever that we can. It looks like we can factor out the 2, then it becomes 4 minus x, like this. Well, this one here is that form, remember that form? So it'll be x here, x there, and we try to identify this 2 number combination. Multiply to be negative 12, added to be negative 1. Multiply to be negative 12, added to be negative 1. So what would that be? That would be negative 4 plus 3. All right. And try to identify the common factor between this. Now, this and this, they are almost the same, but they are not in the same order. This is x minus 4, and this is 4 minus x. So let's talk about this. 4 minus x. We would like to rewrite this as negative x. I'm going to write this first, and then plus 4. Because if there's nothing there, then we can assume that there's a plus there. Okay, and this next step is a little bit unnatural, but again, this is common trick that they use all the time. Unnatural, but common. So what they try to do, they try to factor out the negative from here. So, if I factor out the negative, that should be x, right? So when you put the negative back, you have this negative x. What about this plus 4? What do I need to have here when I put the negative back? It becomes plus 4. Well, that's negative 4. Remember, if I put this negative back into this parentheses, this would be negative x, this would be positive 4. So we can rewrite this into this. Why would I want to do that? Well, if we do that, then we can keep this, we can change that to something like this form. Okay, so let's rewrite this. So this would be, let me put this negative in the front. So it'll be negative 2x minus 4. See that negative right there? That goes here, right? Over now x minus 4, x plus 3, just like that. All right, now you notice that we have same x minus 4, x minus 4 now, so we can cancel these two. Then that's right, we have negative 2 on the top. Bottom we have x plus 3. And let's identify those x values that will make denominator equal to 0. From here, x cannot be equal to 4. Because if it's 4, 4 minus 4 equals 0. 0 times whatever. If it's 4, then it'll be 7, but we don't really care because 0 times whatever is 0. So we don't want that. And also, x cannot be equal to negative 3 from here, right? And it's also from here. So this that we need, and this is what we need. Solution for this question. And I mean, the rest of examples are very, very similar. Basically, you try to factor it first, identify common factor, and you try to cancel it, identify what value of x will make denominator equal to 0, and so forth. So they are pretty much the same thing. Let's try another example now, D. This time it's going to be again slightly different. So this time we have x squared minus 2x plus 1 over x cubed plus 1 times 4x squared plus 4 over x squared plus x minus 2. So we have one rational expression times another rational expression. So it's basically a factoring question, I think, because you factor everything you can, then identify the common factor, right? Oh, you know what? I made a mistake here. That should be x, not 1. So sorry about this. This should be x. Oh, didn't really work. Okay. All right. So let's factor this. Multiply to be 1 add it to be -2, so that must be x minus 1 and x minus 1. You know, that part right here, you can also use the perfect square formula if you want to. But you can just factor it like this. This, you can factor x out, then it's gotta be x squared plus 1, like this. Okay, let's look at this. You can factor 4 out, then x squared plus 1. This, you can factor it out, like that. Multiply to be -1, add it to be 1, so that must be plus 2 minus 1, right? Okay, now let's identify the common factor. First, see this, oops, I want the red color. Okay, see this and this are the same, so we cancel that and cancel that. And this with this are the same, so cancel that, cancel that. So when we cancel all that, then what's left behind? Top part we have 4 and this, right? So we have 4 and x minus 1 top part. Bottom part we have x and x plus 2, so it'll be x and x plus 2, like this. That's our answer. All we need to do now, identify any x value that make denominator equal to 0. So from here, we don't want x to be equal to 0. From here, nothing, because this is a square, result will be either 0 or positive number. You will never get to 0 in this part. From here, we do not want x to be equal to -2, right? If this is -2, that becomes 0. And from here, we do not want x to be equal to 1, right? If it's 1, is 1 minus 1 equals 0. So all this that we do not want x to be, and every other x is fine, right? And that's our answer. Okay, now let's do one more. So last example of this kind. Let's say we have a rational expression, but this time it's a little bit more complicated. Say x squared is 4, and on top of that we have x squared minus x minus 12 over x to the cube minus 8. Now this is like complex form. Well, but you know, they're not that crazy. What we need to do, write this one in here. Let me just use this pen. X plus 3 over x to the square minus 4. Now we're going to write this one. So this goes here, this one in here. But when we write, this is going to be flipped. This is going to be flipped. So this in the denominator part, x to the cube minus 8 goes here. And this numerator part now goes to denominator. X squared minus x minus 12. Just like that. Right? And it's, you know, it's the same thing as the previous example then. Once you identify like that, then factor whatever that you can, and that's it. Cancel it and write the answer. So again, you can pause video now and you can try this on your own and check the answer with me. Okay, so this would be x plus 3 this difference of square x plus 2 x minus 2, right? This times, remember that formula, so this would be x minus 2 and x squared plus 2x plus 4, right? Plus 4. And the bottom part right here, I'm going to put x and x and multiply to be negative 12, add it to be negative 1, so negative 4, positive 3. All right, negative 4, positive 3. Okay, now let's cancel. This and this are the same. Cancel, cancel. And this are the same. So cancel, cancel. Anything else? Probably not. All right. So now what's left behind would be this. So x squared plus 2x plus 4, okay, and over x plus 2 x minus 4. It's like that. And let's identify any number that makes denominator equal to 0, right? Any one of those. So including this or this or this or this, anywhere, right? So x cannot be equal to plus 2 minus 2, right? From minus to plus 2. So negative 2. X cannot be equal to 2 from these two. And x cannot be equal to 4. X cannot be equal to negative 3 from these two, right? Okay, so this is our answer, and we should also mention this along with this. Okay.